So today we are going to look at 2022 menstruation. 2022 menstruation, which was question number 11b. So we are saying the diagram shows a bin, B, C, D, E. So B, C, D, E, this is the bin. So we draw this bin. So this is a bin. So this bin of B, C, D, E, with the radius which was given, which is 8 centimeters here. Then the height for this was H. So now we are saying this bin was cut off, which was cut off by cutting off. Which was made by cutting off the smaller cone. So a smaller cone, you have got a smaller cone. So can you draw the smaller cone? This one. So this was cut based on that. So this small cone is A, D, E. So that was the small cone which was cut. Then for this small cone, we have been given the height, which is 9 centimeters. And then the radius for the smaller cone is given as 3 centimeters. Then now we should take pi to be 3.142. So we should take pi to be 3.142. Then given that AF, which is the height of the small cone, is 9 centimeters, and BG, which is the radius or the bigger cone, is 8 centimeters. And then we have 3 centimeters as the radius for the small cone. But for the height, for the bigger cone, we are not given. We add 9 plus H. So here, first of all, for us to calculate the value of H or to find the volume of the cone, first of all, we should have the data, what we are presented. So what do we have? So we say data, correct data first. So what we have here, we have got 2 cones. There's a bigger cone and a small cone. So we start with the bigger cone. So a bigger cone, what is the height for the bigger cone? How do we find the height for the bigger cone, which is H? How do we find the height for the bigger cone? Anyone? Okay, try. How do we find the height of the bigger cone? How do we find the height of the bigger cone? Let's see inside.
To find the height of the bigger cone, we add 9 plus H.
So we add the height of the small cone plus the height which is not given. So the height for the bigger cone, we are saying 9 centimeters plus 80 centimeters. That is the height for the bigger cone. Then now, also we find the radius of the bigger cone. What is the radius of the bigger cone? 8 centimeters, right? So the height is 8 centimeters. Then we go to the small cone, which is H. What is the height of the small cone? 9 centimeters, right? So the small H is 9 centimeters. Then the small radius? 3 centimeters. So 3 centimeters as the radius. So now for us to find the height, or we say radius height, we divide it by the radius. We replace it in terms of ratios. We express them as ratios. So we say H over R should be equal to H over small letter r. So for H, capital letter H, we have 9 plus what? H. Then for radius, we have, what is the radius? 8. Then what is which is 9 over 3. So from there now we cross multiply. We cross multiply. What is 3 times 9?
27.
Yeah? 27. 27. What is 3 times H? 3H. So make sure when you are multiplying here, don't just multiply. You made the mistake yesterday. You make sure that when you multiply by everything, by h. So multiply this to distribute throughout. So what is 8 times 9? 72. So now from there now, place items together. Place items together. So you have 3h is equal to 72 minus 27. So 3h, what is 72 minus 27? 45. So 45. So both sides by 3, both sides by 3. So that our h should be equal to, what is the 3 into 45? 15. So 15 centimeters. So this is a value for what? For h. So it means that the height here, this height is 15 centimeters. So that when you are finding the height for the bigger cone, add 9 plus 15. What is 9 plus 15? 24. So meaning the height for the bigger cone now, you can change this to be 24 centimeters. So here we have found we have found our h to be 15 centimeters. That's the value for. So meaning here we have answered the question 1. This is 2 marks. 2 marks. Then this is 4 marks. So now, having found this now, we find the volume now, since we have got our h. So now here we just get the data which we have. So here, the data, let's go back to our data. Okay, so let's go back to our data. So here now, let's go back to our data now. Since we have found h to be 15, so our calculated h now it will be 9 plus 15, which is what? 24 centimeters. Then our radius will be 8 centimeters. Then pi, we have been given pi to be 3.142. Then the small letter h we have what? 9 centimeters. Then the small letter r we have 3 centimeters. So this is the information which we have. Then now we can find the volume of the beam. So the volume of the beam, for us to find the volume of the beam, we say volume of the bigger cone now, the bigger cone minus the volume of the smaller cone. So how do we find the volume of the cone? The volume of the cone is given by 1/3 pi r squared h. That is the formula we use to find the volume of the cone. So now, having that now, we are going to place, when you find the volume of the bigger cone, then you subtract it by the volume of the smaller cone. So, volume now of the beam, because we are finding the volume of the beam, will be equal to, so if you combine these formulas, because here this will be the bigger cone minus the small cone. Small cone, which is 1/3 pi r squared h. So now from there now, look what is common. What is common here is found this side and that side. What is common? Because this is calculated r, this is calculated h. What is common here? Maybe. What is common? So maybe please go now. In charge. 1/3, yeah? Apart from 1/3, what do we use? Pi. Even pi is common. So we can factor out pi. Pi of what? 3 is common. So that here will remain with what? R squared, then h, minus here will remain with, we're going to remain with r squared h like that. So that our volume of the beam will be equal to, our pi is 3.142 over 3. Then our calculator r is 8 centimeters. What is 8 times 8? 64. So 64 times height, the height is 24. 24 minus r, the small letter, the radius is 3. 3 squared, what is 3 times 3? 9. So 9 times, what is 9 times 9? 9. So 9 times 9. So that our volume of the core of the bin will be equal to 3.142 times, what is 64 times 24?
1,556.
1,556. So we have 1,536 like that.
Yes.
Then minus 81. 9 times 1, 9 is 81. So divide this by 3. So that our volume or the bin will be equal to, what is that minus times that? Fine. So you punch this on your calculator. Punch in your calculator. Start your punch. You have divided by 3. You are getting what? Okay, someone to verify. Verify. And what have we found?
1,500.86.
That's what we have found. Crystal will verify as well. Yes, Mora. What have we found? What have we found?
1,523.87.
So 523.87. That's what we have found, Mr. Bell. Okay. So now, here, this is centimeters cubed, since it's volume. So now, in mathematics, we are told that when your final answer is not exact, meaning this is not exact figure, it's leveling decimal, you have to round off to the nearest to 3 significant figures. You have to round off to 3 significant figures. So now, here, how many significant figures do you have on this side? How many significant figures? All these are significant figures. So 1, 2, 3, 4, 5, 6. So you have 6. But we have to round off to the nearest to 3 significant figures. So rounding off these to 3 significant figures. Here we are going to round off to the nearest 10. Rounding off to the nearest 10. Nearest 10 meaning our volume now for the bin will be equal to 1, 5. So nearest 10 meaning the 3 will be the one which will be affected. So the nearest 10, this is 23.8. So what is the nearest 10 of 23.8? Is it 30 or 20?
20.
20, right? So 23 is near to 20 than 30. So this will put 20 centimeters cubed, like that. Then we have round off this. Our answer is into 3 significant figures because the 0 here is not a significant figure. Any question, challenges? Okay.